Okay, so we're still doing 2.8, function operations and composition, but now we're going to find the domain of composite functions. So when we put the functions together, we have to find the domain of this new big function. Okay, so these are our 4 steps. So first we find the domain of the inside function, and then we evaluate this composition, and then we find the domain of this, and then we put the 2 domains together, we union the 2 domains together. Okay, so let's have a quick look at what that really means. So step 1, here's my function f, and here's g of x, and it says find g of f of x. So first we have to write it in the way where one function is on the inside, and it's always in order. If g comes first, g comes first. This means that f is on the inside. Okay, usually we have like g of 4, but we don't have a 4 this time. We have a function on the inside. Okay, so we say g of f of x. So we first find the domain of the inside, which is f of x. Okay, so remember, when we're finding domain, we have two things that are difficult, 2 restrictions. When we have a fraction, we cannot have a 0 on the bottom. So for example, here's a fraction, okay, a rational expression. This cannot be equal to 0. And then you would solve for x to find the restriction. When I have a square root, this cannot be a negative number. So I have to take this and say, you have to be bigger than or equal to 0. So we have 2 restrictions that we have to look out for. So here I have a square root, so this cannot be negative number, so I have to make it bigger than or equal to 0. And I solve, and it says x has to be bigger than 8. Okay, x has to be bigger than 8, looks like this. Can it be equal to 8? Yes, so I color in the circle, it's a closed circle. Then I have to evaluate this composition. So it says put f inside of g, so f inside of g. So wherever there's an x, I'm going to put the square root thing. So I put the square root and I square it because it says squared. And a square root and a squared sort of get rid of each other. Are there any restrictions on a straight line? No. So because there's no restrictions on a straight line, that means the domain for this is just negative infinity to infinity. So I have this domain and I have this domain. Now step 4 says I have to put them together. I have to say, what do they have in common? What do they have the same? Well, they only have this in common. So this should be actually like that. So the union of these 2 is this. Just a minute. Okay, so when I have, this should be intersection here. So what I want to do is I say, okay, x has to be bigger than 8, and this can be everything. We have to say, what do they have in common? What do they have the same? They only have this part the same. So the intersection between these 2 different domains is x has to be bigger or equal than 8. Okay, so let's do a few examples together. All right, so the first one, let me just fix the focus. A little out of focus. There. Okay, so step 1, well, not really step 1. First we have to just write this nicer. So f of g of x is really equal to f, and then I'm going to put g of x inside the function. Okay, so the first step is to find the domain of the inside. And g of x is the inside function. Okay, well, what's the power on this? a 1. There's a power of 1 on the x, which means this is a straight line. So what's the domain of a straight line? Well, it goes forever and ever and ever this way, uses all the positive x values. It goes forever and ever and ever this way, it uses all the negative x values. So the domain is negative infinity to infinity. Now step 2, I have to find the composition of this. So I'm going to go f of g of x. So that means I have to put g of x inside this one. So wherever there's an x, I'm going to put this. So I have the square root. I don't put x, I put this where the x is. So 4x plus 2. Can I make this more simple? No, so I have to leave it. So remember, when I have a square root, it's bad to have a negative number under here. It doesn't work. That's my restriction. So here, I have to say, when I need to now, for step 3, find the domain of this. So the restriction is, this has to be bigger than or equal to 0. Okay? So I have to write this, everything that's under the square root has to be bigger than or equal to 0. Now I'm going to solve for x, so minus 2 on both sides. Divide by 4. And that, I'm going to write this as a decimal, negative 0.5. So this says, that's infinity. Oops, that's positive infinity. So it has to be, here's negative 0.5. It says x has to be bigger than negative 0.5. And here it says it can be equal to, so I'm going to color that circle in. So if I want to write it in interval notation, I have to go like this. But see, it says equal to. I can't use this bracket. I have to change it to a square bracket because it says equal to. Okay. So now, step 4, what do the domains have in common? Domains have in common. What do they share? What do they have the same? Okay, so if I do negative infinity to infinity, and I have this, well, they only have this part in common. So my domain for my new function that I've created, my composite function, is going to be the domain that they share, which is just this. There, this common part. Okay, so let's do the next question. Given f of x and g of x, find g of f of x. So now g is going first. F doesn't always go first. Sometimes g goes first, and that's okay. So let's just first write it nicely. G of x is really equal to g. And then f of x is on the inside this time. So step 1, I need to find the domain of the inside. So f of x is the inside, so let's write it out here. So remember, the two problem areas are things that we have restrictions on are fractions and square roots. So here I have a square root, so we can't have negative numbers in a square root. So I have to take whatever's under the square root and say you have to be bigger than or equal to 0. Oh, well, it's already solved. There's nothing else to write. So here is 0, negative infinity, infinity. It says you have to be bigger than or equal to 0. It says equal, so I color that in. So that's my domain for the inside here. So now step 2, I need to actually find the composition. So g of f of x. That means I have to put f of x into g of x. So wherever there's an x, I'm going to put this. So I go 4. Instead of x, I'm going to erase this, and I'm going to put this function. Can I put the 4 and the 2 together? No, I can't put anything together. I just have to leave it just the way it is. I can't make it any more simple. So now step 3, I need to find the domain of this. Well, the whole thing. Do I have any restrictions? Fractions and square roots. I have a square root, so I have a restriction here. So I have to say, everything under the square root, which is just an x this time, has to be bigger than or equal to 0. What's the same as this? Well, step 4 is what do the domains have in common? What do they share or have the same? Well, they're exactly the same. So the domain of this new composite function is this. Okay? So let's look at the next example. So step 1. Find f of g of x. So f of g of x, I put my f first, and that means g of x is on the inside this time. So step 1, I have to find the domain of the inside. So g of x is my inside. Okay. So 2 places where I have restrictions are fractions and square roots. I can't have the bottom of the fraction equaling 0. So this cannot equal to 0. Okay, so what does that look like? It really looks like here's negative infinity, infinity. All the answers are good, but there's a hole at 0. It says we cannot have 0 as part of the answer, or as part of the domain. So now let's go to number 2. Step 2. Now I have to find the actual composition. So f of g of x. That means this has to go inside here. So I would write f of x, but instead of the x, I'm going to write this. Okay, so now, let me pause it for a second, I have to sneeze. Okay, so now what are my 2 restriction areas? Fractions and square roots. Well, here I have a fraction, so I have to say this cannot be equal to 0. So I have to say cannot be equal to 0. So let's solve for x. So add 3 to both sides. Then I get 1 over x cannot be equal to 3. How do I get rid of this x? If I go x over x, that's equal to 1, right? So if I extend that and go, if I multiply the top by x, that gets me x over x. So I can multiply this by x. So that means that's equal to 1. So I really have a 1 left. 1 cannot equal 3x. Now I want x by itself, so I'm going to divide by 3, divide by 3. So now I have x cannot equal 1 over 3. So now I have negative infinity, infinity. And now it says I have a hole at 1/3. Okay, so it says all the answers are great for the domain except for if I pick x equals 1/3. Okay, so now I have to have my restrictions. Step, oh, that was my, here's my domain. I need to find the domain. That was for finding the domain. So now step 4, what are my restrictions? Okay. We can pick the common areas. The common thing, the areas that they have in common are everything but not 0 and not 1/3. So I'm just going to draw a picture because sometimes it's easier. So here's 0 and here's 1/3. So we can choose any x value but not 0 and not 1/3. So now I have to write this in interval notation. So first I'm going to write this interval, -infinity to 0. I don't put a square bracket because I can't be equal to 0. It has to be a round bracket. And a union together with the next one, 0 to 1/3, round brackets because it can't be equal, union with 1/3 to infinity. So that's my final answer. That's the domain of this new function that we created through composition. Okay, so I have to say what are my restrictions and put them together. Okay, it can't be this, it can't be this, so I have to put them together and make a new domain. So let's do another question. Now g of f of x. So let's write it nicer. G of f of x. G comes first, so g comes first. F is after, so f is on the inside. Okay, so step 1, I need to find the domain of the inside. So f of x is the inside. So what are my things I have, my problem areas? I have to look out for fractions and square roots. I have a fraction. I can't have a 0 on the bottom. So this cannot be equal to 0. That's a problem. So let's solve for it. So x cannot be equal to 3. So my answer can be everything but not 3. Okay? So there's a hole at 3 for f of x. So now I have to find the composition. So I'm going to step 2, g of f of x. Now f of x goes on the inside, so this has to go into this. So I would have 1 over x, but I don't have 1 over x. I'm going to put this instead of x. So here, on the bottom, I have this. Oh, this is horrible. I don't like that. It's an awful thing. So what I'm going to do is, because it's kind of messy, I'm going to try simplifying it a little bit. Okay? So I'm just going to rewrite this as 1 divided by this big thing. That's the same. That goes 1 divided by all of this. So I'm just writing it horizontally. So you know when you have 2 plus 3 equals 5, or 2 plus 3 equals 5? This is vertically, and this is horizontally. So I'm just writing it the same way. So we don't like divide, but we can change it to multiply and change this to the reciprocal. Move it upside down. So x minus 3 over 6. I just flipped it upside down. So now 1 times anything is just the same thing. So this is just really 1 times this, which is really this. Okay, so now it's a little bit more simple. Okay, so now I'm going to look here and say I have 2 problem areas, a fraction and square root. I have a fraction, and it says I can't have 0 on the bottom. Well, that's okay. I'm never going to have 0 on the bottom. I have 6 on the bottom. So are there any restrictions for this? Nope. So my domain is going to be -infinity to infinity because there's no restrictions. Okay, so I found my domain. Okay, and so now I have to look at the domain of f of x and the domain of my new composition and say, what do they have in common? Well, they have everything in common, but except for this little hole. So this is going to be my domain. So how do I write this? Well, I have to write this interval and put them together. So my domain is going to be negative infinity to 3, and I union it together with 3 to infinity. That means it cannot be 3, because see how I don't have square brackets at 3? It says you cannot be equal to 3, you cannot be equal to 3, so there's a hole at 3. So that's my domain of this new composite function. Okay, let's look at the next. Oops. Uh-oh, I don't have the next page. Let me pause it. Okay, so now I want to show you that f of g of x is not equal to g of f of x. Okay, so it says find f of g of x. So we write it first, that's equal to f, and it says put g of x inside. So this has to go inside this. So instead of x, I'm going to write this whole thing. Okay, so I'm going to distribute the 4 out. So it's 8x squared plus 20x plus 1. So now it says, I can't simplify that anymore because that's a squared, that's an x. So now let's write it this way. Now it says write g of f of x. So now f of x is on the inside. So now f of x needs to go into g. So I'm going to go 2, and instead of x, I'm going to write this thing, 4x plus 1. It has to be squared plus 5 times 4x plus 1. Oh. So I have to do my exponents first. Remember BEDMAS. Okay, exponents come before divide and multiply. Okay. I can't do anything inside my brackets because 4x plus 1 I can't put together. So up here I'm going to write 4x plus 1 squared. Well, that means write it twice. And then we're going to go first, we're going to multiply it like this. Okay, so 4 times 4x is 16x squared. This times this is just 4x. This times this is 4x. 1 times 1 is 1. And these two can go together to be 8x. So if you want to do it the quick way, you just go 4x times 4x is 16x squared. 1 times 1 is 1x. 1 times 1 is 1. Multiply them together. 4x times 1 is 4x, and you need 2 of them. So that's 8x. So we still have the 2 in front, and we're going to distribute the 5. So that becomes 20x plus 5. Now we have to distribute the 2. So that's equal to 32x squared plus 16x plus 2 plus 20x plus 5. So this and this can go together. This and this can go together. 16, that's 36x plus 7. And we can look that this is definitely not equal to this. So I can say f of g of x is not equal to g of f of x. So be careful when you write it. If f comes first, f comes first. And the thing that comes at the end, g of x, goes on the inside. Okay? So now the last question. We have to look at this and say, okay, if I've already substituted g of x into f of x, what is g of x and what is f of x? What are the two functions? So it's saying, what is f of x and what is g of x? Well, let's rewrite this. This is f of g of x. So that means that this thing on the inside is g of x. So g of x is equal to the inside stuff, x squared minus 5. And if we take out this x squared minus 5 and just replace it with x, it's going to be x3 minus 4x plus 3. So you can see I replaced this with my x. So you can sort of see f of x. So my f of x is just x3 minus 4x plus 3. So if I substitute this into here, you can see you'll get this. Okay.